Good morning, dear students. Today we are going to study about the another concept of atmospheric refraction, and that is advanced sunrise and delayed sunset. You know what is this phenomena that we see every day? It is not observed, it is actually happening. Okay. Now what is happening? The sun is visible to us 2 minutes before the actual sunrise. When the sun is rising, we can see the sunrise means 2 minutes before. Fine. And same way when the sun sets, then again it is delayed for 2 minutes. Okay, actually it has set, but we still see the light. So 2 minutes before we see the sun when sunrise is there, and 2 minutes still late we can see the sun shining. Okay, before the setting of the sun. So it means that during the day 4 minutes of extra sunshine we are getting. The sunlight that we are getting is 4 minutes more as the daily whatever the happenings are there. Okay, so let us see how it happens. Actually what happens is that earth, as you know, is spherical in shape, and the atmosphere that I have shown with this circle is atmosphere that is enveloping the earth. So what happens is when the sun is rising, before that when it is still not risen but we see that it has risen, actually what is happening, the rays that are coming from the sun to the surface of the earth, the rays that are coming from the sun to the surface of the earth, to the observer's eye, what happens? It again goes through the atmospheric refraction. And what was atmospheric refraction? That various densities of layers are there till the surface of the earth. So the rays that are coming from the sun, they are going through the atmospheric refraction through various layers of the earth of various densities. As a result, what happens? The sun is still here, but it feels us that like it has risen. Okay, so it is still 2 minutes to come to the rising state, but we can see it because of the atmospheric refraction. What is happening actually? The crossing of the horizon by the sun. Okay, by actual sunrise, what do we mean? That sun has to come here. That is actual sunrise, but it appears as if it is here. Why? It has risen. Why it is so? Because of the atmospheric refraction. Same thing happens when the sun is setting. See, from this horizon the sun is rising, but from this horizon what will happen? Sun is going to set. So delayed sunset. Delayed sunset means what? That the time difference between actual sunset and apparent sunset is about 2 minutes. So how much difference is there? 2 minutes again. 2 minutes difference for the sunrise, actual and apparent. Same way, when the sun is setting, it actually appears as if it is to set. Okay, but it sets 2 minutes later. So this is again due to the atmospheric refraction. So here the question can be asked that what or how the advanced sunrise and delayed sunset takes place. How the advanced sunrise and delayed sunset occurs. What is the phenomena behind it? And you can be asked in one word also, in MCQs also, that the sun rises or sets how many minutes time difference, on how many minutes time difference. So it is 2 minutes. And how much additional daylight that we are getting every day? That is 4 minutes, because 2 minutes earlier sunrise and 2 minutes later sunset. Okay, so this is about the concept of the atmospheric refraction, showing advanced sunrise and delayed sunset. Okay, now let us see the next concept, and that is the sun appears to be flattened like this when at the sunrise and the sunset. Let us see how it happens. Now, as you can see, this is the horizon, and the observer is always on the this line, on the earth, okay, earth surface. At this time what happens, that when the observer sees the sun during this place, means at sunrise or at sunset, both the cases are at horizon. Now what happens, the two rays that are coming from the lower edge of the sun and the upper edge of the sun, the rays from the upper and the lower edge of the sun, they bend unequally. They bend unequally. Bend unequally. Okay. Now, when this bending of rays takes place unequally, then while traveling through the atmosphere, what happens? The phenomena appears as if the sun is oval or flattened. Okay, it is oblong, oval or flattened, flattened like a disc. So it happens either when the sun is here or the sun is on the mode of setting, both the ways. If sun is here, then also the rays from this side and the rays from this side, they are going to be into the eyes of observer when the observer is looking this side. But because it is going to set, but at that time the again this appearance, when, because it is passing through, the rays are passing through the or moving through the various densities of layers, so atmospheric refraction is taking place. So the sun during setting or during the rising, at both times it appears as if it is a flattened disc like structure. Okay, but when the sun is overhead, okay, means sun is like this on the, this is the observer's eye, and at that time what happens, when the rays, sun is overhead, overhead means at noon, when it is above our head, at that time what happens, the rays that are coming, they are equal on both sides. Okay, the rays that are coming from the sun towards the observer eye, that is what, that is not unequal, they are equal, equal rays are coming, because it is like overhead condition. So at that time there is no bending of rays taking place. The rays are not bending when they are coming at 90-degree angle. So straight away they are coming, so it appears like a circular, okay, circular form in the circular form. Sun appears to be circular, but on the edges, when it is on the horizons, whether sunset or whether the sunrise, it appears like a disc, flattened over disc. So I hope I am clear to you. If the question comes in exam regarding the sunset and sunrise, that advanced sunrise and delayed sunset, okay, time differences of 2 minutes in both the cases, or the question comes regarding this, that it appears to be like a flattened disc. So what you are going to mention? You are going to mention about the atmospheric refraction. So you will tell about atmospheric refraction. Now let us come to the next concept, and that is scattering of light. The next one is scattering, S-C-A-T-T-E-R-I-N-G, scattering of light. What is scattering of light? You know, this is the process taking place in our atmosphere, and because of that only we are able to see each other. Okay, so the concept that we are going to deal is scattering of light. What is this? See, scattering of light happens when the sunlight enters the atmosphere of the earth. Now you know that atmosphere is there, and atmosphere contains what? It contains the atoms and molecules of different gases. Okay, in atmosphere what are present? The atoms are present, or molecules are present of different gases, gases. Where they are present? In the atmosphere. Atmosphere contains different atoms and molecules of different gases. Okay. Now what happens when the light enters into the atmosphere? These atoms or molecules of different gases, what they do? They absorb the light. What they do? They absorb the light. And these atoms and molecules of the gases re-emit light in all directions. Okay. First they are absorbing the light and then they are re-emitting. Re-emitting means re-emit means again they are throwing into the atmosphere in all directions. Okay. Now this process of first of all absorbing the light and then re-emitting into the atmosphere is called scattering of light. What is scattering of light? That the atoms and molecules present in the atmosphere, they first absorb the sunlight and after absorbing, what do? They re-emit in all directions. In all directions. You have to learn this type. That when the light enters into the atmosphere, the atoms and gases present of different atoms and molecules of different gases, they are present in the atmosphere. So what do? They absorb the sunlight and then spread or they re-emit in all directions. And this process of or the phenomena of light is known as scattering of light. Scattering means bikharna. Okay. So in all directions it is being spread. So now when these light radiations, when they come and scattering of light takes place, then what happens? We are able to see different type of colors also. Okay. Now why it happens so? Now there are different types of size of atoms or molecules, like dust particles are there. Okay. What else are there? Moisture is there. Some water droplets are there. So all these things, when they are present in the atmosphere, what do? They scatter the different components of light. Like you have learned, how many components of light are there? 7 components. What were they? Vibgyor. Okay. So this Vibgyor or violet, indigo, blue, green, yellow, orange, red components of light are scattered by the different size of the particles. Fine. So like here we can talk about Tyndall effect. Do you remember Tyndall effect? We had learned in 9th class. It is the phenomena of scattering of light by dust particles or smoke particles or tiny water droplets that are suspended in air. Okay. Scattering of light. I am speaking again. Tyndall effect. Tyndal. Okay. Double L. Tyndall effect. What is Tyndall effect? It is the scattering of light. I am writing here the scattering, SCATTERING. Scattering of light okay, by dust, comma, I am talking about the different particles that are suspended in air. Dust, smoke and tiny droplets of water suspended in air is called the Tyndall effect. Okay. So examples of Tyndall effect are like when you might have observed that if your room is closed and it's quite dark, so from some hole a light ray is coming, that beam of light that enters in the room through that tiny hole. Okay. So what you are going to see? The path becomes visible to us and you can see that some dust particles are there which are moving in a very chaotic manner, very random manner. Randomly they are moving in that. Okay, so or you might have seen that when the light coming through the leaves of the trees, that is also an example of Tyndall effect. Or the light coming through the clouds, that is again an example of Tyndall effect. Okay, so this Tyndall effect is seen in the surroundings. Now, how this Tyndall effect is seen? Let us talk about, because we are talking about the scattering of light. So here what happens when the sunlight enters into the Earth's atmosphere? So these various size of atoms and molecules or dust particles or water droplets, they are present in the air. So what do they do? They are of different sizes. So what they will do? They are going to scatter the light of different wavelengths, like the very small wavelength lights, just like violet, indigo, blue, they will be scattered by very small particles. Okay, and the ones which are large, they are going to scatter the larger wavelength, just like red. If I write like this, VIBGYOR, so these are the ones which are of bigger wavelength, higher wavelength, and these are the ones which are of lower wavelength. Okay, so these are scattered most, and the red will be scattered least. Okay, so you can see the different examples of this scattering of light in nature.